Thanks, Joyce. Yeah. So we're going to start first. I'm going to spend a little bit of time talking a little bit about what is Datastax and what we do, and then a little bit about the product that I'm talking about today, which is the Astra database. And then I'm going to show you demos in terms of what you can do to use this platform to build a cloud-native application. So who is Datastax? Very quick one. Basically, we are the Cassandra expert. We actually built the Cassandra. Actually, we contributed quite a lot of code to Cassandra, almost about 70% of the code. So what we are offering is basically a real-time or near real-time solution or real-time solution based on Apache Cassandra. And we also open source the technology called Stargate and also the Cassandra. Cassandra is basically the Cassandra on Kubernetes, as well as Stargate, which is a API gateway that we are offering for customers who can download. It's actually a open source, so you can put it in front of a Cassandra database, whether it's from Datastax or open source. You can actually use that to provide the API gateway. And then we also offers our version of Cassandra we call Datastax Enterprise, which is actually a very performance optimized Cassandra database. We actually do some changes in the code to put some secret sauce in there as well. And we are also, providing the streaming solution based on Apache Cassandra as well. You can see my deck. Just 1 second. Don't seem to be able to share my deck. I did share my screen. Okay. Yeah, I can't seem to share my screen. Lynn, I can't seem to share my screen. Yeah. Yeah, can I have API based people who can let me get out and come back again. Yeah, I don't seem to be able to share my screen. Okay. Oh, okay. Looks like I can only show my home tab. Okay. Sorry. I'm sure you can see me now. So this is what we're offering. Um, so in terms of when we talk about cloud native, in Datastax we believe that if you want to be able to build that kind of solution, you need to have a what we call an open data stacks in order to support you from building the cloud native application. Firstly, one of the ingredients is that it must be developer ready. So you must have the modern APIs to actually help you to build your application fast without, if you look at traditional database kind of application, you will have to build a lot of APIs to serve the data to your application. So one of the things that about the open data stacks is that you must have a modern data API, which is running on Kubernetes and can be run on whether public, private, or multi-cloud environment. This is what we think from a to build a open modern data application. Now, if you look at what we have today, you can see that what we're offering in the middle. You can see we're offering the Cassandra database and also some streaming technologies. The good thing about Cassandra database, and I'll talk a little bit more about that, is that it's a multi-model database. You can support the column-based key values or document APIs. So providing you with a very modern API for you to build. And on top of that, we provide a support on the Kubernetes as well to provide you a single control plane to support the application that you want. And then what we do is that we wrap around all this database with a target API, which is API gateway, to enable you to be able to do your application, whether going through what we call a CQL, which is Cassandra query language, which is very similar to SQL, and also GraphQL in terms of query and schema GraphQL, REST API as well, also document API. So, and all these things, as I mentioned just now, it can run on any of the platform, AWS, Azure, Google Cloud, even some of these other platform as well, like OpenShift and Tanzaru. AstraDB is actually our own database as service solution, which actually helps in terms of, from a TCO perspective, actually help to improve a lot of that compared to a traditional database implementation. Now, what is Cassandra? So I'm going to quickly talk about what is Cassandra, and then I'm going to show you the solution, how it works. So Cassandra basically is a very highly available solution. The reason is that if you look at typical database implementation where you have multi-nodes database, there will always be, and most implementation will have a master and slave kind of configuration. But in Cassandra, it's not a master and slave. Every of the node in the database can serve user requests, whether it stores the data or not. So let's say if you're creating a node of, let's say six node, a database of 6 nodes, and you say, I want to replicate the data to 3 nodes, and I can access my data from any of the 6 nodes because internally it will go to the nodes that have the data, get the information and give it to you. So there's no downtime because of master node failure. Typical if you look at traditional database configuration is that when one node is down, the remaining node will talk to each other to nominate another person as a master. In this case, no, we don't have a master. Everybody is what we call a coordinator. Okay. The other thing is that it's linearly scalable. So when you add more nodes, you get more CPU capacity, you have more operation that you can support as you add more nodes. And it's actually designed to be a very fast read and write database. So it's very low latency. And as I mentioned just now, it can run on any cloud. So this is what Apache Cassandra is. So it's a NoSQL distributed database. This is single node, so you can have one node and you can add multiple nodes, right? So as you add in more nodes, you increase the number of transactions you can support per node. Remember, I mentioned just now that there's no master node. There's typically in master slave configuration is that you talk to master will point you to the actual server that stores the data. But in this case, because we allow multiple application, multiple replication of data, they connect to each other, they talk to each other and know each other's configuration, and they actually know what each other nodes, what kind of range of data that each node shared or store. And then, when there's a request coming from any of these nodes, it will know that this node store your data. You'll talk to the node, get the information, and send it back to you. Okay, so it's actually configured as a ring, kind of the topology. So each one of them, well, I would say topology. It is a ring, but each one of them can talk to each other. Okay. So this is how when we talk about Cassandra, it's actually a distributed database. So if I have a table here, it doesn't store in one location. So basically, what we do is that we actually put the relevant data in the right partition, in the same partition, so that whenever you want to access the data, it will always come from that particular servers that store all the data in the partition, so that you don't have to run to multiple servers to extract. Okay, and also in a typical database, your database will store the data everywhere on the disk. So what that means is that whenever I want to get a range of data, I got to scan around the disk to extract the data that I want. Whereas in Cassandra, it's actually stored in one single partition where it stores everything together. So this is how we store the database, right? You store the data in multiple nodes, and each one that relevant to, but in this example, countries will store in one particular location. Okay, so that when I access, let's say I come from this node, I know where it's come from. I said I want the USA. These nodes will say, well, USA is actually stored here. I will extract the data from USA. I'll ask the USA, give me the data, and I'll give it to you. So it's distributed. The other thing I mentioned, I think I've talked a lot about this already. So whether you run on the cloud, whether you run on premise, you can actually configure it in a way that you can replicate the data among different clouds, or within the same cloud, among different clouds, or with an on-premise. So you can actually, distribute your data across different regions, different data centers, different cloud providers, and also internal. Now, I mentioned about Stargate just now. So it's basically a data, it's actually an API gateway for our data platform. So when you want to build a solution, typically mentioned just now, I'll show you a little bit later on. This is basically a API gateway that enable you to be able to access the database, whether using GraphQL, whether using JSON, REST API, or document-based, key value-based, or gRPCs. So if you want to do gRPCs, we support that as well. And it's actually Stargate itself is open source. It can run on whether virtual machine or Kubernetes or in the cloud. And it's actually integrated, I mentioned just now, with our AstraDBs. So that will make developing your application easy. If you look at traditionally, when people do an application like full stack app, you will have a backend that interact with your application to serve your data. Every time you want to change something, you got to go to the backend and change, because your schema changes, your backend have to change, because in order to provide that data, you have to go back to backend. So it is taking a lot of time, and people spend a lot of time at the backend to do that. And I'll show you later on how you can avoid that. Okay. And then AstraDB, I mentioned just now, is our database as service. So basically it's running on Kubernetes. So it have all those APIs for you to be able to do the management or operation, to support or to integrate with your, let's say you have microservices or you have DevOps, you want to integrate with your environment. We actually support that as well. We have the APIs for you to integrate. And because it's Cassandra, it supports different kind of protocol as well and different programming languages. Okay, so let me quickly show you Astra. So let me. So this is Astra. Okay, so the address is actually astra.datastax.com. You can sign up for free. So there's a free tier that you can sign up without your credit card that you can use to build a simple application for your testing. Basically to look at how it works and to integrate your application before you even sign up to run your application. So you can click on sign up, put in your username, IDs, and that's it. There's no credit card required. And by default, it'll give you $25 free a month. You refresh every month. So every month you have $25. Depending on how much storage you have, you deduct from there, but the balance will be what you use. So this is Astra database. So you can look at the instances. If you go to the dashboard, you can see the database that you created. You can see there's also streaming as well. You can see I have a streaming solution here as well. It tells me exactly how much read, how much write I'm doing, the storage I use, how much data transfer I do. Okay, so if I go to the database itself, now this is the interesting part, because if you look at most database, right? So this is the database interface. It show you what kind of key spaces. Key spaces is actually it's a container. It's like a database, right? You create a database. So in this case, we say create key space. So it's different. It's very similar from a database concept, although we also call this a database, the whole thing. But this is a key space where you use to interact. It gives you the health, right? You can see, how's the performance like, whether how much read going through, what is the write latency, the right size distribution, some of this information, the range latency, the read latency, basically showing the information. Now, interesting part is that you can actually connect to the database, and connecting to database is very straightforward, right? So you can see I'm using, right, so these are key spaces. So the access of database, this is what we call CQL. So very similar to SQL. Example. Oops. Right, it's just normal standard query. But the interesting part about this solution when you build your application, unfortunately I can't show my screen, but yeah. So there are many different ways to accessing your database. Right. So this is an example. If you go to this connect tab, it'll show you different ways. What you need to configure. It'll give you. Sorry, I don't think you can see that, but it'll give you the Swagger UI if you want to look at how you can call the application. So this is how you can access a database directly without going through your typical backend to support. And we do have authentication as well. So if you want to build application with authentication, we do support that as well. And I'll show you a little bit about that later. So there's a GraphQL as well if you want to use GraphQL. There are a GraphQL playground here that you can access. There's a REST API. right? So you can use REST to access. There's also a drivers. If you want to use your drivers, like for example, Node.js to access your driver, you can do that, right? gRPCs, if you use Node.js, gRPCs, you can do that. And also integrate with Spark. Now, let me show you how you can use your. So this is Swagger API. And you can see that we have quite an extensive range of API. The moment you create your database, it automatically allows you to see the in the interface, right? To be able to show the APIs straight away accessing your table. For example, let me show you how I can retrieve rows. Okay. Okay. Let me put in my token. Right. So remember just now I do a users. I can put space and everything, and the REST API will actually extract the data for me, right? So you can see that when you build the application, you can actually do it without building a backend to serve your data. It's cloud ready, natively available for you to serve your data. The other thing is that if you go to right, so this is API. So when you build your application, you can use the your HTTP, put in the token, and then you can straight away access the information. Same for updating, right? So you can add a row, right? Put in the token, providing a key space, and users, and then you can put your information there, the column name, and then the value that you want, and then you can submit your request. So with this, you can actually save a lot of time from your building your application without going through, building up your backend, right? And then I'll show you a GraphQL as well. Let me, okay, so let me show you the GraphQL. This is a bit troublesome. So this is a GraphQL interface. So you can actually, I need to put in the authentication, right? So let me put in the authentication code. And then if I want to, let's say I want to check the key space information, right? And it will extract the information for me. What are the tables that I have? What are the definition of tables? If I want to query a database, right? Let's say if I want to create, let's say I want to change something about creating what we call a user-defined data type that I can use in my database. I can do that as well, right? And it'll tell me it's successful. So all these things are automatically available the moment you build a database, that you don't have to specifically build something to just to serve your data, right? For example, I can create a table here, right? And I'm using the data type as well. So right? So you created the table. If I want to do a query, I can do a insert the data as well. It will insert. Oh, sorry, this is a schema. Uh, so I need to put in my base, and then I can insert. Oh, sorry, my database is not built properly yet. Um, let's say. So I've not created a table. Sorry, let me create another table for me to do. Okay, articles. Um, let me create a multiple table. Okay, so let me go to the base and create. Oops. Table connection. Oh, so connection error on my side. Oh, sorry. The wrong place. It's the it's not the local host. Sorry, it's the wrong place. Let me try to. Um, so basically, what I need to do is to provide the right link, which I'm giving a wrong link there. Um, this is the right place. Oh, sorry. Hmm. Sorry, I'm very rusty on my GraphQL. Um, so you see my point. So you can actually build a GraphQL interface from there. So what else? So other than GraphQL, and there's a document API as well. Unfortunately, this application doesn't allow me to share my. Let me see. It doesn't allow me to share my Postman. Otherwise, I would love to show you the Postman interface. No, it doesn't allow me to show my Postman. Sorry about that. Um, let me go back to the Astra database. So, so this, as I mentioned just now, when you do a GraphQL REST API, or the moment you create a database, you straight away will be able to see the table. So let me show you what I mean. The moment I create, just now I have a users here. So if I create another table, let's say user 2, email, and then so I created a table user 2, right? So if I let me try to insert that. Two, now. So let me use some of the data to and then recreate. And then first name, Alan, last name, password is sorry, this is a UUID, is a number, right? Right, so user 2 is created. So if I go back to my Swagger again, Swagger UI again, straight away I can get rows. So try out. Oops. Let me get my token. I use user 2 and so, oh sorry, this one is I need a primary key. Retrieve all row. Okay, so user 2, right, the one I just created, and straight away you can see that I just retrieve one row. So with this, you don't really need to build a backend just to serve your data. So, and when you, every time when you create a data, when you change or when you build a table, all these are available, whether it's GraphQL, Document API, or REST API. You'll be able to straight away have this information. You can see that I retrieved from user 2 rows. This is a REST API from the server in our Astra with the key space is IWCRM I created, which was what I showed you just now, the database that we create, the user 2 that I created just now. So you'll be able to straight away have the information. And there are authentication. Let me see what is here. There are authentication URL as well, which you can use to get the authentication information if you want to have that kind of client secret, getting your token and use the token to extract that, or all these tokens can be created here in the database itself. So I can go here, organization setting, and I can create a token here. As you can see, I can multiple tokens. So there's a various role. You can also customize. For example, I customize a role here, but there are default role. You can also integrate with your Active Directory as well, LDAP if you want to. So I can create a, let's say, a read-write users or data administration role. It will just give you the permission that you can have there, and then I can use this. It'll give you a client secret and also the token that I used just now for me to access the system. So this is how we manage that from a user perspective, right? So you can create multiple, invite different users to your environment, but you don't need to. Basically, to access database, you only need to create a token for them to use to access the database. Okay. So any questions so far from people? No? Right. So and the other thing is, well, if you want to, you can enable what we call CDC as well, which is actually a change data capture solution. If you want to, push your data, let's say from, you want to push your data, the table name, and then you can enable. So you can push your data to a remote location if you want to do that. So if I enable that, it will actually allows me to create, to configure where I want to save my data and do a streaming of data. So the usage is that, for example, if you have application, you want to stream your data into our our Cassandra database or our Astra database for you to do analysis. For example, you want to do, analytic, machine learning, or those kind of application. You can actually use the CDC to capture change data and send the data into, let's say, you want to send it to Elastic Cloud. You can actually do that as well. Yeah, that's all I have. Any questions so far? No? If there's no questions, that will be the end of my session. Thank you very much.